with us. So for those that don't know our guest just by looking at him, his name is Dennis Hayes, really a legend, a pioneer, not just here in Atlanta, but within the technology industry. Anyone that's familiar with the early days of the early computer industry, personal computer industry, will know a company called Hayes Microcomputer Products that invented and really, again, pioneered the modem and really internet communications on those first early computers. So Dennis, thank you for joining us, and love to talk more about some of your background, what you've done, and then of course some of your current initiatives that I'm happy enough to be a part of as well. So again, thank you.
Well, thank you for having me. First of all, let me say that the Hayes Microcomputer Products created the PC modem market segment in the PC industry. There were modems before that, but generally they were used mostly for lease line connections, where you would connect a remote office to a data center, or they were what were called acoustic couplers, where you would take the handset of the telephone, put it into the cups on an acoustic coupler, and be lucky if you get 300 bits per second transmission, because any background noise would interfere with the communication. But it was a way of connecting to the telephone line before the Part 68 was passed at the FCC, which allowed for the little modular connector you use today to connect into a wired phone line, if you can find one anywhere anymore. It seems like almost everyone has gone to smartphones.
Yep.
And it's hard to find a regular telephone set connected to a wire that goes to the central office. That's pretty much a technology of the past. But in the early 80s, as the PC industry was getting started, that was the way that people communicated, was with telephone lines. And that was before smart modems were available to send data, before smartphones were available to make phone calls. And we used the available technology to enable the early PC users to connect to information systems or transfer files between computers. Or the big thing at the time was the bulletin board systems. The bulletin board systems were sort of a precursor to the internet. The internet protocol and the internet architecture was created by DARPA for connecting mostly government research computers and with academic research computers. And turned out that protocol, packet switching network, was a good solution for scaling out to the general public. And that's where we got the internet.
And now, so I think you touched on a great point that you didn't even you don't consider yourself the inventor of the PC modem as, Wikipedia does, right?
No. Well, there's a distinction is between the PC modem and the modem.
Okay.
Western Electric, Bell Labs invented the modem. We invented the category of the PC modem, which is a product category that did not exist before we started making them. There were 2 or 3 early competitors, and we defined a new product category, a new market segment, as the PC industry got started. We started with the Apple II. Well, actually, we started with the S100 bus in 1978, 77, 78. The S100 bus had a circuit board that could plug into a computer bus. It had a 100-pin connector, so they called it the S100 for standard 100-pin connector. And there were several computers at the time. The first was the Altair by MITS, M-I-T-S. They were actually got started in Georgia. And then the MSI came along and was a little bit more robust chassis for holding the boards. And then there was sort of an explosion of several dozen different companies that made S100 bus compatible computers. And so our first product at Hayes was the we call it the 80-103A data access adapter for the S100 bus. And it had a serial port with a modem built in. You plugged it into the computer bus, and then software could talk to it through what's called a UART, a Universal Asynchronous Receiver Transmitter chip. And that was a chip that turned serial data into characters that can be read by the computer bus. And it took characters out of the memory into the computer bus into the UART chip and turned the parallel bit output of the computer bus into serial data that could be transmitted through the modem. And the UART also had the functionality of adding start bits and stop bits to make it asynchronous communications, consistent with the ASCII standard, ASCII. What was that? American Standard for Communications Information Interchange or something like that.
Yeah, American Standard Code for Information Interchange.
Yep, it's pretty close.
I was showing Jim, I pulled up a picture of the 80-103A and showed him, and then he did one of those gestures, like it going right over his head. And it's just amazing how much you're able to recall in such technical detail.
Well, we built those. We started out, you could get it one of two ways. You could either get a bare circuit board with instructions how to build it yourself. It was a technology at the time based on what's called through-hole technology on the circuit board. So all the components would stick through the circuit board. The leads on the components would stick through holes on the circuit board, and an individual that was relatively skilled with soldering could solder the parts in and assemble it themselves. Pretty soon that went away because most customers would prefer to buy it assembled and tested and know that it was going to work when they plugged it in, and not have the hassle of going to find the parts. But all the parts were off-the-shelf standard components, except that the filters on the next generation, which was the Micromodem 100, were hybrid filters that we had to supply, but by then very few people wanted to build it themselves. The hybrid filters had a substrate with a number of components mounted on the substrate, and it was a module that connected into the circuit board. So the second product that we did after the 80-103 was the the Micromodem 2 for the Apple II. And if you remember the Apple II, I think it had 8 slots across the back of the chassis. Basically, the Apple II was pretty flat and had a nice molded chassis that the motherboard laid in, and across the back of the motherboard there were 8 connectors you could plug devices into. Well, one of the features there was you could put read-only memory or ROM memory on the circuit board you plugged in, and then you could direct the computer, the Apple II, to use the code on that plugged-in board to run that device. So when we first delivered the Micromodem 2, we used a Control-D for dial so that it would activate the dial software on this board. And like a month later, Apple came out with a disk drive and used the Control-D for the disk. And so we had our first change so we changed it to Control-Q to get away from things Apple would be likely use. So the Control-Q was used to dial the modem on the micromodem too. And the other thing we did when we introduced the micromodem 2 was we developed what we called the microcoupler, which was a small box that was on an umbilical cord outside the computer that allowed you to connect directly into the phone line. That was one of the earliest data connections into the phone line under Part 68 of the FCC regulations. Some years earlier, there had been a big lawsuit. The Bell system was a closed network. You had to get equipment from them. You had to get your phone from them. You had to get your modem from them. And in order to open that up, actually Carter Phone brought a lawsuit against the Bell system, and they won. And the result was the court required the FCC to create a method that allowed companies to make equipment that could attach to the phone line. So the result of that was what was called Part 68, which defined the modular connector and the specifications for the testing you needed to do. And each company was required to do the testing and submit the results to the FCC in order to get approval to connect. Now, when we did that the first time, we called up the FCC and said, well, what are the rules for doing the testing? And they said, well, you've got the test specs. There are no more specifications. That's it. You have to do the work and turn in your report. And I looked around at our guys and said, okay, treat it like we were doing a physics lab at Georgia Tech,
right,
or a chemistry lab at Georgia Tech. Describe the configuration. Say what the test is. Describe the configuration you use to do the test. Show your data. Show your calculation, and show your conclusion. And so we did that. And shortly after we turned it in, they called us and said, can we show this to other people because nobody's known how to do it?
Wow.
And we said, well, we figured it was public information since we're giving it to the FCC. So, no problem. We don't consider it copyright because we're responding to the requirements of the regulatory environment to show that we've tested it properly. And of course, we wanted anybody else who did it to not damage the phone network. So that actually worked pretty well.
So